Hello everyone, welcome to today's lesson. In today's lesson, we will talk about finding the derivative from first principles or using first principles. Now the derivative function from first principles says, let f be a function. The derivative of the function denoted f prime, that little apostrophe here is read prime, is a function whose domain consists of those values of x such that the following limit exists. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. This is also called finding the derivative using first principles. So this function here, this equation, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now let us look at some examples of how we can use this. So let's consider the same derivative from first principles equation. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Use this equation to find the slope of the tangent line to the graph of f of x is equal to 2x plus 1. Then find the slope when x equals 4. So we need to have values for f of x, which we have here. Then we need to find values for f of x plus h. So f of x plus h be equal to, wherever you see x, to find the f of x plus h, you simply replace the x with the x plus h. So it'd be 2 bracket x plus h. Notice we replace the x with x plus h, then plus 1. All right, don't put an x plus h if you only see a number, just where you see the x. Then simplify it, and at the end for part B, you plug in x equals 4 if needed. Right? Not all the time it will be needed, but in many instances, it will be needed for you to again do another plug-in. Okay, so let's look at part A. For part A, we write down what the original function was, which was f of x is equal to 2x plus 1. Then we try to find f of x plus h by replacing the x in the original equation with x plus h. So wherever you see x, you're going to put in x plus h. So we're not just adding an h to this or x here, we're actually replacing this x with x plus h. So then we can expand it 2x times 2h, that's how you get it, 2x plus 2h here, and then plus 1 just goes out at the end. Right, so your f of x plus h will be 2x plus 2h plus 1. Then we are going to look at what our derivative function was h prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So where you see f of x plus h in this function here, we're going to replace it with what you calculated for the f of x plus h here. Minus f of x, you're just going to put back the f of x that you had here into that equation. So now it becomes a limit h approaches 0 of 2x plus 2h plus 1 minus brackets 2x plus 1, which is your f of x. So you put in your whole f of x value in the bracket here. And then we can distribute the minus through in the next step. Right, all of this divided by h. Now it becomes a limit as h approaches 0, 2x plus 2h plus 1 minus 2x minus 1, because a negative times a positive here gives a negative, so you distribute it to a negative to a positive, it becomes negative, so that's minus 1 all over h. Notice the 2x will undo the minus 2x, the plus 1 will undo the minus 1, so you're left with the limit as h approaches 0 of 2h over h, and so that will simplify to just 2, right? Because the h's undo each other right here by division. Now, since your f prime of x is equal to 2, then the value of the slope when x equals 4 is 2, because there's no x to plug in at 2, so it's just 2. So whatever value that we get for x, it will always be 2, because the slope will always be 2, right? The derivative will always be 2 for this function 2x plus 1. Let's look at another example. Consider the equation f prime of x is equal to limit h approaches 0, f of x plus h minus f of x, and use that equation to find the slope of the tangent line to the graph of f of x is equal to x squared. Then find the slope when x equals 4. Again, you're given the derivative equation. Not in all questions you'll be given. Sometimes you just be asked to find the derivative of a function from first principles. So this here is something that you have to remember. So what is f of x? F of x is equal to x squared. What is f of x plus h? You replace the x plus h, forget the double equal sign, is just a single equal sign should be here. X plus h squared, right? So let's do that. F of x is equal to x squared. F of x plus h, you replace the original x with x plus h, so it becomes x plus h squared. If you expand this, it's going to be x squared plus 2hx plus h squared. Now plug that into the derivative formula, and so f prime of x is equal to limit as h approaches 0 of x squared plus 2hx plus h squared, and then subtract f of x, so that's minus x squared. Note that the x squared and the minus x squared undo each other. So we are left with, and that is over h, by the way, so we're left with the limit as h approaches 0 of 2hx plus h squared all over h. Now we factor the h from the top, and so we have the limit as h approaches 0 of h bracket 2x plus h all over h. Now the h at the top divides into the h at the bottom, right here. These two, the factored one, not the other one, the factored one, and the h in the denominator. So we're left with limit as h approaches 0 of 2x plus h. Now we have to plug in h equals 0 right here, so it becomes 2x plus 0. Notice the limit drops because you have plugged in the 0 to the h here, so it becomes 2x plus 0. So but 2x plus 0 is simply 2x, so the f prime of x is equal to 2x. Now we want to find the slope when x is equal to 4. So the f prime of 4, what we do, we replace this x down here in the 2x with 4. So that's 2 times 4, and 2 times 4 is equal to 8. So the slope is 8, or the slope of the tangent line is 8 when x is equal to 4. Now let's look at a third example. Consider again the derivative from first principles equation. F prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x all over h, and we're going to use that equation to find the slope of the tangent line to the graph of f of x is equal to x squared minus 2x plus 1. Right, that's a little bit longer than the one that we had earlier. And then we're going to find the value of the slope when x equals 2. So then your f of x is equal to 2x squared, it's equal to x squared minus 2x plus 1. And so the f of x plus h, wherever you see x in the original, you replace with x plus h. So it's going to be x plus h squared minus 2 times x plus h plus 1. So let's do it. F of x is equal to x squared minus 2x plus 1. F of x plus h will be x plus h squared minus 2x plus h plus 1, because we're replacing the x's with x plus h. Now, if you expand all of this out, it's going to be x squared minus 2hx plus h squared minus 2x minus 2h plus 1. We're going to put this into the f prime of x formula. So f prime of x is equal to limit as h approaches 0, x squared plus 2hx plus h squared minus 2x minus 2h plus 1 minus your original f of x, which is x squared minus 2x plus 1. Then we're going to distribute the negative through the brackets, and so we're going to have the limit as h approaches 0 of x squared plus 2hx plus h squared minus 2x minus 2h plus 1 minus x squared plus 2x. It becomes a plus here because a negative to a negative gives a positive, minus 1 because a negative to a positive gives a negative. Now look at the terms in there, and the x squared will undo the minus x squared, minus 2x to the 2x, and the plus 1, the minus 1. So then it becomes the limit as h approaches 0 of 2hx plus h squared minus 2h over h. So that's a limit as h approaches 0 of h. You factor out the top now. H is in all the terms, so we factor out the h bracket 2x plus h minus 2, all divided by h, but notice there's a h in the top that's factored out, and you got to only undo the factored out h with the denominator. So then it becomes a limit as h approaches 0 of 2x plus h minus 2. At this point, we plug in the h equals 0, and so it becomes 2x plus 0 minus 2, which is 2x minus 2, because anything you add 0 to, it remains the same. That's 2x minus 2. F prime of x is equal to 2x minus 2. So part B, when x is equal to 2, what is the slope? So the f prime of 2, we're going to plug in 2, where you see x, so it's going to be 2 times 2 minus 2. 2 times 2 is 4, so that is equal to 4 minus 2. So the final answer is 2. So the slope is 2 when x is equal to 2. That means the slope of the tangent line to this function at x equal to will be 2. Thank you.